All right, so we did handling movement. Let's go ahead and just really not quickly knock out rotation and scale. And I'll just shift these. I'm holding Alt and the up and down arrow key. Again, I apologize for the Mac. I'm not sure what the hotkeys would be for that. So let's go ahead and do scaling next. All right, so when we look at scaling, what we did before was we used the input got get key axis, which is really the axis, which is here when we're pushing the arrow key, right? So it's moving as minus, between negative whatever and positive whatever, and we're storing that in this horizontal value, and we're using that to actually translate our character, right? So if we look at this transform.translate, we take the direction, which is again storing x, y, and z. And when we use this translate method, which is created by Unity, and we plug a direction in here, what's happening is it's registering whatever we're pushing, those WASD keys or the arrow keys. And we're multiplying it by this move speed variable, which we had before. So we're saying, okay, I'm going to do 5 times whatever that key press is. If we don't have this in there, it's going to move fairly slowly. Now, the next thing is to normalize the value or the speed. We add time.delta time. So what I'm going to do is I'm just going to duplicate this twice, and then I'm going to comment out this top line, and I'm just going to get rid of this code here. And I'm just going to show you the difference between direction. Let's duplicate this. And then this one is times move speed. And then this is with all three. Okay, so let's comment out each one of these really quickly. I just didn't want the last video to get too long. So I'm going to go ahead and just say, okay, we're going to do transform.translate by direction, which just means by the X, Y, and Z axis, remember that we have going on. So if I press play now, let's give it a second to think. And I push my WASD keys, you can see it's hyper quick. So let's say that let's comment this one out here. And let's do move speed. Actually, let's just do one where we're doing just times.delta time. So time.delta time, remember, update runs every frame. So your computer, which might be faster than mine, might have a higher frame rate. That means it's able to render more frames quicker. The slower the computer, it renders less frame rates. So by adding time.delta time, it normalizes it so that we're using the time between each frame. So that actually normalizes it. It makes the playing field even for anybody who's doing any sort of movement in game. The problem with that is it really slows down the movement of the let's see, did I save this? It actually slows it down a bit compared to what it was before. So if I press play now, it's gonna still appear to move pretty well. See that? But it's still, see how it's much slower. And that's why combining all three of those attributes together, where we take direction times move speed times time.delta time, gives us a much smoother result in movement. So now you can see we get a bit more control, and then I can crank up the move speed here, and I can really control the move speed of my cube here. So let's go ahead and just delete all of this. Now the next thing is we have this rotation here, and I just set it to 90. Now this might be new to you, and what we're doing is we're saying, hey, I want to grab the input of the key, which is the Z key. And by using get key, it allows me to press or hold my Z key down, and it'll continuously register that movement, right? So if I'm pushing my Z key, what I want to do is I want to transform, which is this attribute here, the local scale of this. Sorry, I forgot that I moved those around. I want to take the local scale, which is this right here, and this plus equals, if you haven't seen it before, is really the shorthand of just writing transform.local scale equals transform.local scale plus, and I'm just going to put this on a new line just so you could see it. As long as it's one continuous thing with the semicolon, you could put them on another line. This equals whatever the current scale is plus 1 times the scale speed. So vector 1 is whatever it currently is, like 1, times time.delta time. And this evens it out, right? So let me go ahead and delete this so I can show you this in action. And what we're going to be doing this on again, is we're just adding to the scale, and then when we push Z and then X, we're just subtracting it. So this will make our cube go bigger and smaller based on pushing Z and X. So if I click in here, remember you always have to click in your game view to make sure that it registers that. Now when I push Z, notice it's scaling, and I push X, it's scaling down my cube. All right, let's look at the rotation here. Same thing here. When I press Q, I'm going to grab my transform rotation attribute here, and we have 90 degrees here for the value. And what we're saying here is, hey, I'm going to do vector3.up, which is it's just referring to this axis here, right, our y-axis. And I'm going to rotate, I'm going to do a negative rotation speed, which is minus 90 times time.delta time. And that's when I push Q. So let's see that in action. So if I push Q, you can see it's rotating on that y-axis. And if I push my E key, it's rotating the other way because it's not negative. So we're just taking the inverse of the positive and negative value. In the next video, now these concepts, again, sorry, I hit Control S for a second. These concepts are not necessarily advanced topics. This is just a base for me to build our advanced topics as we move through the class. What we're going to be doing the next thing is we're going to be talking about something which can be considered an advanced topic, and that is scriptable objects. And these are phenomenal ways of storing data so that it can be used across multiple scenes. And we're going to be doing that in a very basic way. We're going to create a scriptable object that stores the move speed, rotation speed, and scale speed. And we'll do that in the next lesson.